I have here, with the help of AI, 20 questions on cloud administration and solutions architecture. General cloud, not any specific single cloud. You probably won't face an exam on this, but the concepts will help you anyway, and you might also be asked these questions in an interview. This is quite common, especially if you're going for a cloud engineering job. So let's get into this, see if you know your subject. Question 1. Which of the following cloud service models provides the highest level of control to the user? I have actually been asked this question before. So, but I've been asked in a different way to define something within one of these different things. But yeah, highest level of control to the user, I guess it's going to be, I don't know if they mean a normal customer. They're probably SaaS. If they mean an infrastructure, you know, a user, a cloud engineer or something, it's going to be IaaS, I would imagine. Let's see what it says here. Says here, okay, IaaS, exactly. IaaS provides users with the most control over their compute resources to manage server storage and networking, while the cloud provider handles the underlying infrastructure, does the undifferentiated heavy lifting, the management. Okay, next question. Question 2. In a multi-cloud architecture, what is a key benefit of using a cloud management platform? Multi-cloud. Cloud management platform. Okay. Well, increased vendor lock-in is not a good thing. It's not a benefit. Latency, nothing to do with it, I don't think. Data replication, never. I think it's this one. Centralized governance and cost management. Let's have a look. See what it says here. Indeed, centralized governance and cost management. A cloud management platform enables organizations to manage multiple cloud environments from a single interface, streamlining governance and optimizing costs across various services. I actually don't know about any of these cloud management platforms. So that's very interesting that this is a kind of multi-cloud product now. Okay, let's look at the next question. Number 3, which of the following is a primary characteristic of serverless architecture? Right. Dedicated servers. No, that's very old, and these are just normal kind of like virtual machines, really, but managed. Persistent VMs. No, I don't think it's this, because serverless is the key word here. Event-driven execution. Yes, and that's just a common feature of serverless. It's generally used for event-driven execution. Manual resource provisioning. Of course not. It's got to be C, event-driven execution. Let's have a look. Let's have a look. Answer C, event-driven execution. Explanation. Service architecture allows for code execution in response to events. Automatic scaling of the resources as needed, without the user managing servers. Exactly. Question 4. What is the primary role of a VPC, virtual private cloud, in cloud computing? Obviously nothing to do with storage. To create isolated network environments. This sounds like it. Isolated networks. You know, segregated, separated, isolated. Optimized app performance? No. Data sovereignty? Not specifically to do with the networking, although, you know, there is segregation. It's got to be B, isolated network environments. Let's have a look. Yes, B, isolated network environment. Explanation. VPC allows users to create private networks within a public cloud. Private networks within a public cloud, providing control over IP addresses, subnets, routing, and also ensuring isolation from other tenants. Indeed, that's correct. Other tenants means, you know, if there's another company that is also in the same cloud, you are both tenants. The landlord is like AWS, you know, or Azure or whatever. Question 5. Which of the following strategies best supports high availability in cloud architectures? Which of the following strategies best supports HA? Single region deployment. Well, that wouldn't be highly available, would it, if you can only deploy in a single region? Load balancing across multiple zones. This sounds more like it. Load balancing, single entry point, but then across multiple zones. Dependency on a single cloud provider. Well, a lot of people do that anyway, but in itself, it doesn't mean HA, right? Manual failover processes. Okay, HA is kind of like a cloud native concept, which wasn't really possible before the cloud in an easy way, and it definitely is not about manual failover. There's no failover with HA. It's really, there's no, you don't fail over from one site to another, from primary to secondary, you always have multiple sites, and then you can survive one or more going down. So it's got to be B, load balancing across multiple zones. Let's have a look. Question 5. Yes, B, load balancing multiple zones. Distributing workloads across multiple AZs ensures if one zone fails, the app can continue operating through another zone, and therefore you have enhanced overall availability. Question 6. What is a primary purpose of a CDN, content delivery network, in the cloud? Is it archiving your data? No. Is it reducing latency for end users? That's one benefit, yes. Enhancing security protocols. I'll come back to that. Automating app deployments, nothing to do with that. Right, so CDN is like an edge location, and because it's on the edge, it will reduce the latency for end users, and you can cache objects and things like that there, binaries and whatnot. So it reduces latency. It actually, I think, protects the origin whatever's behind the edge location. I believe that it actually protects the origin. So it actually does enhance security as well, but primarily I would say reducing latency. Let's see what the answer is for 6. I think it's B. Let's go down. B, indeed, reducing latency for end users. CDNs cache content closer to users geographically, and therefore reduces load times and latency when accessing web resources. Indeed. So I was right. I'm doing pretty well here. Question 7. Which of the following is a common challenge when implementing a hybrid cloud strategy? So hybrid is part on-prem, part cloud. A common challenge. Okay. Increased performance. Well, that wouldn't be a challenge, would it? Seamless integration of services. It's a bit wishy-washy. I don't really know what they're getting at there. Enhanced security. Is that a challenge? None of these are challenges. They all look like benefits to me. Enhanced security, simplified management. Which is a challenge when you have hybrid? Part on-prem, part cloud. All of these are benefits, right? Increased perf, enhanced security, simplified management. This one isn't. And I think it's saying that it's difficult to achieve this. And I agree. So anyway, hybrid doesn't necessarily mean enhanced security. It may or may not. It depends how you manage it. Management, yeah, I would say maybe if you have on-prem and cloud, you definitely have more to manage. And the on-prem and the cloud are managed in different ways. Performance is neither here nor there. This is BS. It's going to be either the management or the integration of the services, and I think it's probably the integration. But there's much that you can do, to alleviate that, especially on the networking side. So it's going to be B or D, but I think it's going to be B. Let's have a look, see what it says here. And that's what I thought, B. Seamless integration. Integrating services across on-prem and cloud can be complex, requiring careful planning and management to ensure interoperability. It's a little bit wishy-washy. It doesn't go into much depth, but in general, I agree. What you don't want is two separate sites that are like almost like two different clouds almost. You want them, the on-prem and the cloud. You want the benefits of both, but you kind of want to present a similar pane of glass to your users. So I agree. Seamless integration of services is the challenge, and you want to work towards that. Question A. What is the primary advantage of using IAC, infrastructure as code, in cloud management? Manual configuration? Obviously not. Increased error? Well, obviously not, and that's not the case. You eliminate errors. Consistency in environment provisioning? Yes. Dependency in physical hardware? Well, this is not true. It's this one. Consistency in environment provisioning. So when you provision an environment, or I don't know if this is the right word to use. It's not incorrect, but basically there's consistency in provisioning. It is the same, should be the same every time you do it, and that's because of infrastructure as code being declarative. You describe what you want the end state to be, and you let the IAC product that you're using take care of that and give you the same result every time. A consistent result, the same. It's going to be C. Answer to question 8. So it says here, indeed, C. Consistency in environment version. IAC allows for automated and repeatable, exactly, repeatable deployments of info. Reducing variability, ideally should be, pretty much no variability, and the potential for errors in environments. Correct. Question 9. In a cloud-native app, which design principle is crucial for scalability? Monolithic. No, that's the old way. Stateless services. This is more like it. Synchronous communication. Nope. Fixed resource allocation. Nope. So monolithic is the old way, and instead we have microservice architecture, which is loosely coupled and therefore reducing the blast radius and dependencies. I'll also mention the other ones that it definitely isn't. Synchronous comms, no, we're moving more towards asynchronous comms. So you should have messaging within your cloud native application. The messaging is basically like a queue. So instead of relying on things going in a particular order, they can be out of order. It doesn't matter. Let the queue can be polled, etc. Fixed resource allocation. That's obviously wrong for cloud native. You do have sometimes fixed resource allocation, but instead it's ideally better if your app can scale resources as and when it needs to, scale up and scale down. So you're not spending too much money. You're only using what you need to. Stateless is correct. You don't want, wherever your services are sort of doing their computation, let's say, you don't want the storage to be alongside the compute and the memory. You want to decouple everything, including the state. This should be in some kind of persistent storage. So the answer to this is going to be B. I'm pretty confident of that. And there we go. Stateless services. Explanation. Stateless can handle requests independently, which allows for easier scaling by adding and removing instances, so that's like the compute and the memory, without maintaining session information. Exactly. That's more or less what I said. Question 10. Which of the following best describes a microservice architecture? Well, we just mentioned that, didn't we? A single large app? No, that would be a monolith. A collection of independently deployable services? This sounds more like it. A tightly coupled back-end system? Nope, we mentioned loosely coupled, decoupling. Traditional monolithic approach? No. So it's similar. It's going to be B, independently deployable services. Let's have a look. That is a MSA, microservices architecture. And there we go. Answer is B, a collection of independently deployable services. MSA breaks down apps into smaller, loosely coupled services that can be developed, deployed, and scaled independently. That's the key word there. Right. So let's hope for a slightly different question next. Okay, this is better. Number 11. What is the primary function of an API gateway in cloud architecture? Is it A, to store data permanently? No, it's got nothing to do with storage. To manage and route incoming API requests. This sounds more like it. To authenticate users. To provide backup services. Right, so I'll tell you now. An API gateway is like an entry point to your application, and it will route the various, usually HTTP, but can be different requests incoming usually from the outside world, and then to wherever it needs to be within your application architecture. So it's got nothing to do with storing data. It's got nothing to do with backups. And this is primarily what it does: manage and routes the incoming API requests. It does handle it can handle, or does always handle, not sure, but it definitely can handle auth. So this is correct, but the primary function is management and routing the incoming API requests. It's going to be B, so let's have a look. There we go. Answer B, to manage and route incoming API requests. API gateway acts as a single entry point, I think I said that, for clients, that's the word I should have used, to communicate with multiple services, back-end services you could say, and handle routing, auth, so we mentioned that, and, oh yeah, rate limiting as well, indeed. So next question. Question 12. Which cloud deployment model offers the highest level of customization? It's a little bit vague kind of thing to say. Is it public? Is it private? Is it hybrid? Or is it community cloud? I don't even know what community cloud is, so I'm just going to ignore that. Private cloud. A lot of people don't know what private cloud is. Private cloud is when you have a company that will kind of provide almost like a managed service. So, for example, you can use private cloud from a vendor that will provide managed exchange. So it will be Microsoft email, which can be fully managed, but they take on the management and they allow you to access it and maybe to control various things, probably through their own dashboard. So it's definitely not going to be private cloud, because you have some level of customization, but not the highest level. So we're left with public and hybrid. So which of these two would it be? You know, in my opinion, it's going to be hybrid. Hybrid is public and on-prem. Your on-prem. And in my opinion, you can use the best of both worlds. Then you can use public cloud and you can use your own on-prem in your own data center, and that way you have an extremely high level of customization. But I'm not sure what the answer to this is going to be. I have a feeling it might just say public cloud, but I don't actually. I think it's hybrid. Let's see what the answer is here. Private cloud? A private cloud allows orgs to customize their infrastructure network settings to meet specific business needs. I'm sorry, but this is bullshit. That is not what a private cloud is. Now, I will say that there is argument over what the true definition of private cloud is, and I believe it's the one that I mentioned earlier. I don't believe this is true. I think when they say private cloud, I think again this is a common misconception, that sometimes when people say private cloud, they're referring to on-prem. So I think what it's saying here is on-prem allows you to customize your infrastructure and network, you know, in exactly the right way to meet your own business needs, the way you want. So I think when it says private cloud, they mean on-prem. But in my opinion, private cloud does not mean on-prem. I think it's a common misuse of the word. So, you know, I will, if it did mean on-prem, then I would have agreed with it. And that's also why I chose hybrid, because it was public and private. So I'm going to disagree here a little bit, but it doesn't matter. Question 13. In a cloud architecture, what does the term cloud bursting refer to? Is it permanent migration to the cloud? Is it temporary use of public cloud for overflow? Is it a complete reliance on on-prem infra? Or is it redundant backup solutions? Okay, let me talk about bursting. Bursting is when you have some capacity already provisioned, and let's just say it's some kind of predictable capacity. It may not be fully provisioned. It may be that you're still sort of pay-as-you-go type thing, but it's provisioned in the sense that it's sort of what you would normally expect to use and what you can reliably expect to use as well, right, from your provider, let's say cloud provider. Now, bursting is a temporary increase in provisioning that you're allowed, and it's not unlimited. It's not forever. It's temporary. It's not forever. So it's got nothing to do with permanent migration, and I don't know what this is talking about, complete reliance of on-prem, and it's nothing to do with backup. So I've never heard of the term cloud bursting, but I think it's talking about this temporary use of public cloud resources for overflow. And I'll give you the classic example that if you use like an AWS T2 micro, then it's I think all T2s are burstable instances, which means that you can burst over a certain amount, but if you do that, you will consume what's called CPU credits, and they don't last forever. Eventually they're consumed, and you have to back off and let this burstable capacity come back, and then you can burst again at a later time when you have that capacity again. So pretty sure it's talking about temporary use of public cloud resources for overflow. So let's have a look. 13, I think the answer is B. Indeed, cloud bursting allows apps to run in a private cloud. I'm not sure what it's talking about there, and burst into the public cloud when demand exceeds. Okay, this might be a concept I'm not aware of. Cloud bursting could be when you have on-prem, i.e., your data center, your own, possibly your own cage, definitely your own racks, your own servers, and you have cloud on standby to burst when your demand exceeds the capacity that you have in your cage, in your racks, your HP or Dell servers. So I'm not familiar with cloud bursting. It must be something new that I've never heard about. That's very interesting. But there is also, as I said, if you're fully in the cloud, there is bursting. Okay, if you have an EC2 on AWS or an Azure virtual machine or something like that, then you can burst, usually on some types of instance. Question 14. What is a primary benefit of containerization in cloud deployments? Is it increased hardware costs? Well, that's not a benefit. Simplified app scaling. Okay, that sounds kind of good. Dependency on a single OS. Dependency on a single anything doesn't sound good. Complicated deployment process. Well, that's not really what I would call a benefit. If something being more complicated. Okay, so containerization is where you share the host and the underlying OS on the virtual machine on which the container ultimately sits, because the host is the virtual machine. It's running usually Linux, and your containers on there, they all share the same underlying Linux, right? So it's a kind of abstraction and less complications. You don't really have to think about the Linux underneath. So it's definitely not increased hardware, because you have several services sharing not only the hardware but sharing the OS. So you're not having multiple OSs installed on the same, in this kind of virtualized environment, even on the same VM. It's not A. It is B. It's easy to scale containers. You can even put containers in pods and scale pods. That's another abstraction layer. So it's definitely B. Dependency on a single OS, well, usually you do just have a single OS, ultimately, under your container. I wouldn't call that a benefit. You could do that anyway. And a complicated deployment process, well, it's not complicated. It's actually, I would argue, more simple. So the answer is B, simplified scaling with containerizations. Let's have a look. Yes, simplified app scaling. Containerization allows apps to be packaged with dependencies. Indeed. Making it easy to scale them up or down across different environments. Correct. Okay, let's have a look at the next question. Question 15. Which of the following tools is commonly used to orchestrate containerized apps? Is it Ansible, Terraform, Kubernetes, or Jenkins? Orchestrate containerized apps. Okay. The key here is orchestrate and containerize. It's Kubernetes. That is exactly what Kubernetes is for. In fact, if you had the reverse question, what is Kubernetes, then your answer should be it's used to orchestrate containerized apps. Very simple. It's not Ansible because that's configuration management. It's not Terraform because that's infrastructure as code. It's not Jenkins because that is one product used for CI/CD. So its answer is definitely C. Let's have a look. There we go. C, Kubernetes. Explanation. Kubernetes is a widely used orchestration platform for automating the deployment, scaling, and management of containerized apps. Indeed. Indeed. Question 16. Which of the following best describes the concept of IaaS, infrastructure as a service? Now, just you need to know what IaaS and PaaS and SaaS and possibly CaaS, which is container as a service. You need to know the difference between all of those. But in general, IaaS is basically managing virtual machines. That's kind of the easiest way to think about it. So, is it delivery of software applications over the internet? No, that would be SaaS. Is it provisioning of virtualized computing resources over the internet? Yes, that's VMs. Is it development platforms for building applications? Not sure what they mean by that. They could potentially mean something like, well, it says platform, so that's PaaS. So it could mean something like Heroku, or it could even mean something like Elastic Beanstalk. I forget what that's called in I think it's called Azure App Service in Azure, Elastic Beanstalk in AWS, or in Google it's called something else. Basically, where you can, all you have to do is point the service to your repo that contains a compatible runtime, like, for example, WordPress code or a Python app or something like that, and it takes care of everything else. So this is pass C. So it's not C. And D, serverless computing based on events. No, that would be like AWS Lambda, and that's commonly called FAS, which is function as a service. So no, IaaS, infrastructure as a service. I said it was VMs. It's B. So let's have a look. The answer should say B. Indeed, IaaS provides users with virtualized compute, such as server storage and networking, which can be managed over the internet. Okay. Question 17. Which type of cloud storage is best suited for unstructured data? Unstructured. So, structured is obviously like databases. Unstructured is, let's see here. Well, I should correct myself actually, because structured being databases is kind of a traditional view of it, which still does apply, but you can store unstructured data in a database. Structured means it has a schema, it has these predictable fields, and you know, it's quite easy to query in that sense as well. And unstructured doesn't. So you can have unstructured in a database, and you know, with varying fields and things like that, you know, in a JSON format. But let's see. Actually, my bad. I got confused again. If you have something in JSON, then it would typically be what you would call semi-structured data, so that, you know, that the fields will vary and that kind of stuff. It's not as structured as structured data that you would put in a SQL database with predictable fixed fields, but JSON would be semi-structured. The fields might vary. It can be a little bit all over the place. You just need to store key value data. So unstructured just has no structure at all. And I think it's going to be, which one is it going to be? It's going to be object storage. I mean, block and file and tape are, yeah, they're kind of like, well, I don't know what they mean between object and file storage. I guess they mean a file system here, and this is a tape storage, block storage, a file system. And object storage is something you have in the cloud, where you can store objects that are typically files, but it's not a file system. So what they're getting at here is, where can you store things like binaries, which, you know, files and stuff like that, but in the cloud. I think they're getting at object storage. If it wasn't the cloud, you'd probably just say file storage. Block and tape, you can put them there, but they're sort of an abstraction, you know, one place away, further removed, and really, you don't, you know, your hardware will kind of look at that. Or your operating system. It's not something that you'd be too concerned about. So I think they're getting at object storage. Let's have a look. Sorry for the mouthful of an explanation. Yes, object storage. Designed to handle unstructured data, offers scalability and metadata capabilities that traditional storage options lack. Indeed, it has so-called infinite scalability, and you can store metadata, and this is actually becoming more powerful. You can actually query your object storage in a way a bit like a database these days. So that's quite interesting. I don't think the question was phrased very well, and my bad about the that I couldn't quite remember the difference between structured, semi-structured, both of which you get in databases, and completely unstructured or non-structured data, which you know, which is totally different, tends to be objects and files. Let's move on. Question 18. Which of the following security measures is crucial for protecting data in transit within cloud environments? So they're talking about encryption here. Oh yeah, and immediately I can see it. Okay, but anyway, data redundancy, encryption, server location, or public access. If you ever someone mentions about protecting data in transit, that's encryption. So encryption typically will do it in two places. It will either do it in place, in situ, you know, where the data is actually sitting, or also data has to be moved, right? And when it's moved, it's in transit, it's in flight. And you need to protect it then as well. You need to protect it when it's still, and you need to protect it when it's moving. So in transit is talking about when it's moving, and that's encryption. Data redundancy is that's not about protecting data in the sense of security. data redundancy is protecting against data loss, because ultimately hardware can fail, and if it fails, can you still get your data back? Have you stored it in more places than you need to, basically? So it's not A, it's B. The location has nothing to do with it being in flight, in transit. Remember, we said that already. And I don't know what this is talking about. Public access, I guess it's just an answer to just throw someone who doesn't really understand what the answer is. I mean, obviously, you don't want something, if you want to protect it, don't put it in public. Well, it can be accessible from the public, but you want to make sure that in transit, if it's sensitive especially, that it's encrypted. So I don't really know what they're getting at there. It's kind of irrelevant. Let's have a look. It should be B. Indeed, encryption. Encrypted data in transit protects it from unauthorized access and ensures confidentiality as it travels. That's the key. Over networks. Can be over the public internet or can be in your private network. Even in your private network, many years ago, nobody would bother to encrypt the traffic internal. These days, it's considered very important. Not as important as public traffic, obviously. But, a hacker has to still get inside your network first, but still very important now. Question 19. What is the primary function of a CASB, a Cloud Access Security Broker? I've heard of this, but I'm not sure. Let's see what it says here. Store data securely, to provide network info. This doesn't sound right. It's got nothing to do with security. To enforce security policies across cloud services. D, to manage cloud billing. Okay, it's clearly not B or C. It's got nothing to do with security. Cloud access. An access, something to do with security, and it's an access broker. So this has to be used or negotiated or something in order to gain access. It's a broker. It's some kind of entry point. To store the data securely. I don't think it's this. To enforce policies across cloud services. I think it's this, because the key word here is policy. If someone's trying to gain access to something, then it makes sense to me that a broker would say, check the policy to see if this identity, this person or non-human user, check the policy. Check the list. Do they have the access? Do they have the right access? Are they coming with the right credentials? I think it's C. Let's see here. I think it's C. It's got to be C. And it is. To enforce security policies across cloud services. A CSP acts as a mediator, exactly, a broker, between users and cloud and CSPs like AWS, Azure, whatever. Enforcing security policies, ensuring data compliance. Indeed. Compliance. Question 20, last question. Which of the following is a critical aspect of DR, disaster recovery, planning in cloud environments? Data replication and backup. This already sounds like DR to me. Minimizing resource usage. Nope, that sounds more about cost control. Lock-in with a single vendor. I'll come back to that. Manual intervention for recovery. Okay, interesting. Okay. DR planning. Data replication. If you're doing DR properly, you should be replicating your data to another site. And you should also be having backups in another site. So to me, A is the biggest one. It's nothing to do with B. Vendor lock-in. There is a debate about whether you go all in with a vendor or whether you should avoid vendor lock-in and actually have other strategies and use multiple vendors. But it really increases your complexity by a heck of a lot. And I think this is controversial, so I'm going to say it's not C, okay? Because we're concerned with DR planning in the cloud. I'm going to say it's probably not C, but it's not irrelevant. Manual intervention for recovery. As part of your planning, if there's a disaster, right? So high availability is not DR. High availability is when you want to ensure that your app is kind of on the back end, is being served from, let's say, 3 different zones. And if one zone goes down, the other 2 survive. You don't need really, that's not disaster recovery. That's kind of accepting that you will never have 100% availability from a single zone And actually, these days in the cloud, arguably, you don't really have DR. You kind of plan for failure, and you don't rely on having to recover from a disaster. You kind of plan for automatic recovery. So it's a difficult one here. You kind of plan for manual intervention, I would argue, if you're doing DR. It's a little bit old school. So I'm not sure if it's going to be A or D. I feel like A is more relevant, but I actually think in DR that you do want to have a kind of plan for the recovery part when there's a disaster. It's going to require some manual effort. That's kind of what you're setting yourself up for. So I'm not really sure. The other thing I'm going to say is it says cloud here, and I don't know if maybe they're getting a A. And by the way, this is kind of how questions can be sometimes. You can argue that, like, well, maybe they shouldn't have asked it in this way. I'm gonna go with A, but maybe it could be D, that there should be a run book or something. Let's see what the answer that they think it is in this case. The AI that created this Q&A. And it's A, as I thought. Effective DR planning involves implementing data replication and backup strategies to restore services quickly in the event of an outage. Well, it doesn't quite say why D as well. I didn't ask the AI to give me, much longer answers. I decided to provide those discussion points myself. So there we go. That was Cloud Administrations and Solutions Architecture Q&A, which I used AI to help me do. You could get these questions, probably not with 4 choices in an interview, or potentially you could get them in a more specific administration and solutions architecture exam about AWS or Azure or GCP or any other cloud. That they don't always ask you specific questions related to their particular product and service offerings. You do often get generic questions like this. So I hope you found this very useful. Did you get 20 out of 20? How did you fare? Should give you an idea of some of the gaps in your knowledge and what you really need to look at. And these are questions you'll be expected to answer in general in a cloud engineering, and I would also say cloud architecting, and I would also say even in a DevOps and potentially SRE and platform engineering type interview as well, that you may be expected to answer at least some, if not all, of those questions. I've answered those simply from experience, and yeah, if you're experienced, you'll be expected to know those. So hope you found this useful. Let me know what you think, and I will see you again soon. Take care. Bye bye.